All right, section 7.2, exercise 38. Here it says use integration capabilities of a graphing utility to approximate the volume. So I think the idea is maybe we don't know how to do the antiderivative is the problem. And definitely in the one I assigned, 37, you don't know how to do that antiderivative. So yeah, I think the same thing here with 38. And so we need a graphing utility. Um, so what do we have? We're given that the boundaries y equal natural log of x, y equals 0, so the x-axis, x equals 1, and x equals 3, those vertical lines. So when I draw that, log x, it's 0 at 1, and kind of looks like that. So there is our x equal 1, and then x equal 3. So this height would be log 3. And so y equals 0, so the x-axis here, there, and they put in the x equal 1 to, I don't know why they put in the x equal 1. We didn't need that. Yeah, not needed. We're in here. And okay, and then what do they say? They want us to revolve the region around the x-axis. So we're going to slice it up and get disks this way. And so this is a little more straightforward to set up. We have our pi. Our integral goes from 0 to 3. Our r squared is just the height here, which is log of x. Well, r is just the log of x, so we square that, natural log of x squared, and then dx. And yeah, the problem is we don't know the antiderivative for that. So we go to Desmos to get an answer. We need pi times the integral from 0 to 3 of, what is that again? It's log of x squared. So log, I need to find that somewhere, natural log of x and squared, and then dx. And it says it's 9.5. Well, I can get an idea as to whether that seems reasonable. So 9.5 is what we got. Let's go back here. So we're saying this is about 9.51 or something like that, 9.5. Okay, so when you look at this, right, that's a lot like a cone where the radius here is 3. And, oh, sorry, 3. No, sorry. Silly me. Where the radius is log 3. No, log 3. I'm a little slow. So there's our radius. And the height is 2. So there's a height of 2 because it goes from 1 to 3. And now, so the cylinder would be pi r squared, so natural log of 3 quantity squared, and then times 2 for the height. Okay, since it's a cone, what I know, and I don't remember if I gave you an exercise on this, but what I know is because we're going to a point here and we're making this cone, it turns out that we get 1/3 of that area. Okay, so I just know that from geometry. So this cone should have a volume a little bit smaller than this rounded cone up here. So let's go check that out just to see what it is. I haven't tried that. So pi natural log of 3 squared and times 2/3. Okay, so we need a pi somewhere. Pi times the natural log of 3. Now we need to square that. And so we'll do a square there. And then it was natural log of 3 squared, and then I don't remember, times 2/3. Oh, that's not good. Well, I mean, it's not bad, but so times 2 and then divided by 3. So a whole lot smaller. Well, actually, so the strange thing here is, oh, yeah, see, I caught my mistake. Okay. And this, again, is why you try things. You know, I don't do these mistakes on purpose. I'm just really good at it. Okay? I did the integral from 0 to 3. Silly me. Goes from 1 to 3. All right? So I want to get rid of that. And there's a 1. Looks much better. 3.23. And my cone is 2.5. Sounds much, much better. So, you know, let's see. I think I wrote it wrong to begin with. Yep. All right. It was going from 1. I heard you yelling out there through the video. Yeah, sure you are. You're just laughing at me. Sorry, 1 to 3, but once it's set up, you know, and this is the idea of checking one's work. And hey, it may make me look like an idiot, but I am an idiot who can catch my errors. So we have, you know, this is not 9.5. It was what? 3.23. So that's the thing with technology. If I tell the technology to do the wrong thing, it gives me the wrong answer. So I still need to check it. And, you know, so here I knew here I had the right height of 2, but I mistakenly, you know, we've done so many that started at 0, I just automatically put a 0. So we should get a value of about 3.23. So there we go.